So I noticed that this says homework 14, but this is actually homework 13. So let me just rewrite this as 13 here. And let's go. So problem 2, the 3 tanks containing ammonia mixture are connected as shown. Tank 1 contains A1 of T pounds of ammonia in 50-gallon solution. Tank 2 contains A2 of T pounds of ammonia in a 90-gallon solution, and tank 3 contains A3 pounds of ammonia in a 50-gallon solution. The solution is kept uniform by stirring, which means it's going to be the same, and we're neglecting the volume that is in these tubes, just for simplicity. And then that the concentration is going to be the same everywhere. That's what it means when it says it's kept uniform by stirring. The solution is pumped from one tank to the other at the indicated rates. Derive the system of differential equations that models the rate of change of ammonia in each tank. So what I'm going to do is I'm going to color code it, because I feel like color coding things today. So let's focus just on tank 1. What's happening on tank 1? Well, if you remember, just a little review, I'll do it in this color, a little review. We can say, when we had our little problem with one tank, what we could say is that the change in the amount of salt in the tank, so let's just say A, generic A prime, so with respect to time, the change in the amount of salt with respect to time is equal to the rate in minus the rate out. So if we keep this in mind, let's keep this in mind. Let's now go and solve and start modeling from tank 1. So from tank 1, what are we going to get? Well, first of all, we switch to green, and then we're looking at this tank, and we're saying, okay, we have tank 1 is the amount of salt in tank 1 with respect to time. So I'm just going to put a little dot here, mixing notations here. But I like this notation because there's already a 1 here, and I don't want to confuse it with the 1 here. And that's going to be equal to the rate in minus the rate out. Well, what's coming in? Well, we have, let's see, 10 gallons per minute coming in here. So 10 G per minute coming in here. And what is the concentration of the stuff that's coming in? Well, it's coming from tank 3. So if it's coming from tank 3, then it's going to be whatever the concentration at A3 is, whatever the amount, at A3 is, because this is the amount of salt, so in pounds of salt, divided by how many gallons there are in 3, because I said earlier we're neglecting this volume over here. So how many gallons are there? Well, there's 50 gallons initially. That's what they tell us, 50 gallons. And then what we're going to do is we're going to add what? We're going to add all the rates coming out and all the rates coming in. So if from this tank right here. So there's 10 and 5 gallons going out, so 15 gallons per minute going out. And then here we have 15 gallons per minute going in. So at any one time, there's always the same amount of gallons. There's always 50 gallons in. Otherwise, we'd have to take into account that. And I always suggest put it in and then see it cancel by itself. But since this is going to be a big system, I just want to make it as simple as possible. So this is for the first tube right here. This was the first tube. Now let's look at the second one. We have something else going in. So we're going to add this 5 gallons per minute because that's what it tells us. And where is this coming from? Well, that is coming from this tank 2. So A over 2 divided by 90, so A sub 2, sorry, divided by 90 gallons. And notice how the units beautifully cancel out, and we get a rate of the amount of salt in pounds divided by minutes, which is what we want. So we have 5 gallons per minute times A sub 2 over 90 gallons. And once we have that, what are we going to do? Well, once we have that, we're going to, let me see. We're going to look again. We have 5 gallons going out of this tank here. And then we have 15 gallons going out, 15 gallons going in, and another 5 gallons going into this tank. So what are all the arrows that are pointing away are this and this, and they are 20 gallons going away at any one time and 20 gallons going in at any one time, which means that at any one time there's always 90 gallons in the tank. So we don't have to write that down there. And this is our rate in. This is our rate in. I'll do it in gray. This is our rate in. So what's going to be our rate out? Well, we're going to do the same process, but now we're going to look at the arrow going away. So this arrow going away from tank 1. So that's going to be minus 15 gallons per minute. All of that is going to be multiplied by what? Well, it's going to be multiplied by the concentration in tank 1 divided by how many gallons there are at any one moment. And the million-dollar question is there the same amount of gallons at any one moment? Well, we have 15 gallons going in total and 15 gallons going out total any 1 minute. So yeah, the amount is the same. So over here we can just write 50 gallons. And that is how you model the first one. And I'll say that this over here is my rate out for 1. Now let's do tank 2. So let me get a little bit of space here. And we'll do, oh, I don't like this. And we'll do tank 2. So tank 2. Now we're going to do what? Now we're going to be getting this color. Tank 2 is right here. The process is the same. And now one thing that I find interesting is we don't have something that's coming in from here, for example, so from outside. So these are all without forcing function. So the rate of change of salt in tank 2 with respect to time is going to be equal to what? It's going to be equal to the stuff that is coming in, that's the rate in. So we have, and we've already established in all 3 tanks, at any one time, there's always the same amount of gallons. So that's good to know. So now we're looking at this, 15 gallons going in. So 15 gallons per minute going in. We want to multiply it by the amount, well, by the concentration. What is the concentration of this? Well, if it's coming from this way, it's coming from this tank. So it's the concentration of that tank. The concentration of that tank is A sub 1 over 50. So A sub 1 over 50 gallons. And now let's look at what else is coming in. We got these 5 gallons coming in. So plus 5 gallons per minute multiplied by the concentration of that water. Well, that solution is coming from tank 3. So it's going to be A sub 3 times 50 gallons. And this is going to be our rate in 2. Now, let's look at the rate out. We have this 5 gallons per minute, 5 gallons per minute going out of our tank. So that's our actual tank that we're modeling, A2 over 90 gallons. And then we have another 15 gallons going out this way, 15 gallons going out this way. So let me write this as 15 gallons per minute going out from our tank 2, which has 90 gallons total. And so this is going to be our rate out 2. Now let's do the same thing for tank 3. And now I want to also show you how whatever is coming out of one tank and going into the other, like this 15, then we should have a negative 15 gallons per minute times the concentration of this in our first tank. And then we should have a positive 15 with the same concentration because it's the same water. See how the concentration is the same? So this is a good way to check that your model makes sense. Okay, so now we're going to do the last one. Here I'm going to put a little divisor here. I know it's getting kind of crowded, but unfortunately I can't make it smaller than this. And, oh, I don't know what's happening. Tank 3. Now we're going to look at this color over here. And we're going to look at this tank. And we're going to do the same process. Here we're going to have 3 terms. In the first one, see, we had 1, 2, 3 terms. And in fact, we do have 1, 2, 3 terms. And in the last one, we had 1, 2, 3, 4 terms. And if you look at the last one, we have 1, 2, 3, and 4 terms. So things start to look good, right? So now the last one is going to be the rate of concentration of the salt in tank 3. That's going to be equal what's coming in. Well, we got 15 gallons per minute coming in. So we got 15 gallons per minute coming in. And they're coming in from tank 2, which has 90 gallons in there. And we have it right here. See, this water that's going in here, it's coming from this. So it must be modeled by the concentration in that tank. Now, let's look at what's coming out because there's nothing else coming in. Well, we got this right here, which happens to be the 5 gallons that were going into tank 2. So it's going to be the same as what we modeled over here, just with a negative sign. So minus 5 gallons per minute times A3. And in fact, it's coming from our tank, the one that we're modeling, over 50 gallons. And then we have something else, which is going into 1. So let's look at the 1 term right here. Into 1, we have this that was coming in, right? So we will have this over here, which is going to be negative 10 gallons per minute times A sub 3 divided by 50 gallons. And now this is going to be our rate in, let me make it a little bit neater. This is going to be our rate in 1, and this is going to be our rate in 2. So now that we have this is our model. Now, let's model it. They're talking about eigenvalues, eigenvectors. So let's put it in matrix form, and let's simplify it a little bit. So I'm going to use the red to simplify it, and let's see what we can do. So this one, we can say that this is a 1, and this is a 5, and this cancels out. Now, this is a 1, and this is an 18, right? Because 5 into 9 fits 1 time, and then into 40 fits 8 times. And then the gallons cancel. And now this is a 10 and a 3. We simplified by 5, and the gallons go away. This is a 10, and this is a 3 again. In fact, it comes from that one. It just changes the sign. This is a 1 and a 10, and the gallons go away. This is a 1 and an 18. This is a 3 and a what did I say? 18 again. So we simplify, and now we can simplify actually by 15. So if we simplify by 3, these, we're going to get 18 divided by 3, that's 6, and that's 1. And this is, so that's the same thing as that one. So this is going to be a 1 and a 6. The gallons go away. This is a 1 and a 10. And this is a 1 and a 5. So now that we have this stuff, let's write it into matrix form. So I'll keep the colors. So we're going to have, first let me write it neatly here. A sub 1 prime is equal to 1/5 times A sub 3 plus 1 over 18 times A sub 2 minus 3 over 10 times A sub 1. And then, why don't we write it in order? So A sub 1 first, A sub 2, and then A sub 3. Okay, so starting from A sub 1, we have minus 3 over 10. And I got to be careful here, not make any sign mistakes. Plus 1 over 18, A sub 2. Plus 1 over 5, A sub 3. Okay, let's look at the second one. That's in orange. A sub 2 prime is going to be equal. Well, first I want A sub 3. That's 1 over 10. No, sorry. First I want A sub 1. So that's 3 over 10, A sub 1. Then we want A sub 2. And we have 1 over 18 minus 1 over 18 times something, and minus 1 over 6 times that same something. So we can group these together. And we can say minus 1 over 18 minus 3 over 18. So that's minus 4 over 18, which is the same thing as minus 2 over 9. So we'll say minus 2 over 9, A sub 2. I really hope I didn't make an arithmetic mistake. No, arithmetic. I remember this. The adjective is with the different accent. Okay, and now we have A sub 3, which is plus 1 over 10 A sub 3 right here. And now we're going to look at the last one, which is in this color. So A sub 3 dot is going to be equal to 1, well, let's see. We don't have anything coming from A sub 1, and that seems strange. We only have A sub 2, something stuff coming from A sub 3 and A sub 2. Well, but that's what it is. So this is 0, A sub 1. And now we have two things that are coming from A sub 3. So we have minus 1 over 10 and minus 1 over 5. So that's the same thing as minus 1 over 10 minus 2 over 10, which is minus 3 over 10. So minus 3 over 10 A sub 2. But that was for A sub 3, so let's not get confused. Minus 3 over 10 A sub 3. And now here, we're going to have 1 over 6 A sub 2 plus 1 over 6 A sub 2. And now we can write this in our matrix form. So here we're going to have A sub 1. No, I want the colors. So let's do A sub 3 first. A sub 2. And A sub 1. All of this needs to be equal to the coefficient matrix. Here we're going to have minus 3 over 10, 1 over 18, and 1 over 5. The second one is going to be 3 over 10 minus 2 over 9, 1 over 10. And the last one is going to be 0, 1 over 6, and minus 3 over 10. Now we're going to close this up. And here we're going to have a sub 3, a sub 2, a sub 1. And I encourage you to do this and see that you will get this. So this is the answer to part A. I will see you in a second for part B.